Hello everybody, hope you guys are doing well. So continuing on our journey, today we would be trying to learn a little bit more about DBMS, and we'll see. So the first thing that we're going to learn is what is DBMS, right? Now, uh, okay, so let's start. The amount of information available to us literally is uh, so before we move on to DBMS, uh, like we'll try to understand uh, like what's the advantages of having a DBMS, and then we'll see a little bit more about that, and we'll try to install PL, maybe SQL. We'll see, and then we'll go on. So basically, the objective is what is DBMS in particular, and then what is in specifically to understand what is relational model, right? So first, we need to understand what is a DBMS, and then once we know that, then we'll try to understand uh, relational model, and we'll also see. Okay, so then we'll see why should we consider a DBMS to manage data. How is application data represented? How does a DBMS support concurrent access and protect data during system failures? What are the main components of DBMS? Who is involved in databases in real life? And so on. So firstly, the amount of information to is literally exploding, right? And the value of data as an asset is widely recognized. To get the most of the large and complex data sets, users require to use tools that simplify the task of managing data and extracting useful information in a timely manner, right? On the other hand, data can become a liability with the cost of acquiring it and managing it far exceeding and the value derived from it. The database is a collection of data and typically describes. Okay, so now basically here we are at the brief intro about what data is, why. So data is something God, right? I mean, all your data. So data these days is the whole world depends on data, right? Even platforms like OpenAI or ChatGPT, to be specific. Uh, so then the first thing, so DBMS has two things, right? It is a database management system. So first, let's understand what do we mean by a database. A database is basically a place where you store data. It is basically a collection of data. Now, and extracting and managing data typically describes activities of one or more organizations. For example, university data may be included, like which subjects, which courses, which faculty. Okay. For example, now a database management system is a software designed to adjust and so first thing that we have is basically a database. So a database is where the information is kept. So this is the info or data. Now to manage these data, we use a software that is nothing but a database management system. So a DBMS is basically a software designed to assist in maintaining large and utilizing large data collection of data. Not surprising, many dishes. The need for such systems is growing rapidly. The alternative to using a DBMS is to store. The alternative is you can store data in files as well, right? You can have data in file. You can have a file management as well, but then everything has a what do you say? Wait. So you can store data in files as well. Now we'll try to understand why we shouldn't store data in files, or what's the drawback, or what is the advantage, or when to use file systems. The goal of this is basically to understand in-depth introduction to database management systems, with an emphasis how to design a database and use a DBMS effectively. Not surprisingly, many decisions about how to use a DBMS for a given application depend upon what app capabilities the DBMS supports. Therefore, to use a DBMS well, it is necessary to understand how a DBMS works. Many kinds of management systems are in use, but we are going to concentrate on relational database systems, which are by far the dominant type of DBMS today. The following questions are addressed in the core chapter. So basically, database design. Okay, we'll see that. Now, historical. Let's go back to in history. From the earliest days of computer, storing and manipulating data is a major application focus. The first GPO, sorry, general purpose DBMS was designed by Charles Babbage, General Electric, in the early 1960s. That was called the Integrated Data Store. It formed the basis for network data model, which was standardized by the Conference on Data Systems and strongly influenced database systems. Although 1960s, now Batchman was the first recipient of the Turing Award. Basically, the Turing is a great Alan Turing, a great scientist who was able to. Basically, this is during World War II, right? So he may was able to decode, yeah, the Enigma machine. Now, if you want to, can just Google what a Enigma machine is. So if any language that follows uh, the rules set by Turing is said to be a Turing language. Now is equivalent to Nobel Prize. So Nobel Prizes is for other fields like for physics and some other literature or something else. Then specifically to computer science, we get the Turing Award. Then in 1860s, we IBM. Okay, so the first was developed by Charles Babbage at GE. Then in 1960s, IBM developed the information management systems, that is, which is used even today. It forms the basis of the alternate data representation framework called as hierarchy model. Now, this is all okay. Now in 1970s, Edgar at Code at IBM's San Jose research laboratory proposed a new data representation framework called the relational data model. Uh, Later on, we went on, and then we came to relational data. Now Code one, okay, Turing Award, and then database systems matured. In the 1980s, the relational model consolidated in its position in the dominant paradigm, DBMS. The SQL language for relational database developed as a part of IBM Systems R project is now standard the query language. We'll see a little bit about how query and everything is written. Now, file system versus a database management system. To understand the need for DBMS, let's consider a scenario. For example, a company. Yeah, now this is something. This is something interesting to study. For example, uh, a company has a large collection. Say this is a company, right? So I have. He's saying you are having 500 GB of data. Okay. Now, data. Our first employees department questions about the data and other things must be answered. Now we can try to. So what if we store this? What if we didn't have a DBMS and instead we use a file system? Now probably we do not have 500 GB. So basically, if this is 500, not all is available, right? Some part of it might be reserved by the OS. Therefore, we must store data in a storage device. So what we do is instead of storing it here, we have a storage device that can be an SSD, can be an HDD. Now with 32-bit addressing, we cannot refer directly more than 4 GB of data. We have to program some method of identifying all data items. Now we have to write special programs to answer each question we want. These programs are likely to be complex because the large volume of data to be searched. We must protect the data from inconsistent changes by different users. The first thing is, if you are using file system, is you will need an extra drive. Okay. Second thing is managing such big amount of data. Second is there is an issue with the addressing, right? So because we cannot refer to more than 4 GB of data, so again addressing kind of becomes an issue. Third issue is we need to write a special language Basically, that is answer to answer each question the user may want to. You must protect the data from inconsistent changes. So what if this is going to be handled by lots of people, right? There is no set priority who can do what. We must ensure that data is stored. So once if the system crashes or if the SDD goes down, then the data also goes down. So again, the OS can provide only a password mechanism for security. This is not sufficient for flexible enforcing security, right? Now DBMS is a piece of software that is designed to make this task easier. By storing data in DBMS rather than as a collection of OS files, we can use DBMS features to manage data. What are the advantages of data? What is the advantage of using a DBMS or a data management software? The first thing that we have is data independence, right? The DBMS provides an abstract view of the data that an application program shall not ideally be exposed. Okay, so suppose this is a mobile app that is recommending, right? So we don't want our app to be directly exposed. Instead, we will be using some API to connect to our database. Again, that is given by the DBMS. That API thing is provided. Second is basically efficient access, right? We don't want everyone to have the same level of access. Uh, Again, if you are storing data in external SSDs, we don't want everyone to access, right? So we have something called as access. The next thing that the database offers us is um, data integrity, right? And security. Data integrity is one of the so we are and for if you are accessing data using a DBMS or a management system, then there are certain rules that we apply or certain constraints that we apply. For example, before inserting salary, we can check does it belong, whether the department budget has not exceeded or not, or we can enforce access controls that govern data is visible to which level of users. Data administration. Well, several users share the data. Centralizing administration of data can offer significant improvements experience. Again, we have something called as data administration. So we can perform some level of data administration there. Then we can do something called as concurrent access and cross recovery. This is something cool. A DBMS schedules concurrent processes access to data in a manner that users can think of the data being accessed only one user at a time. So each user thinks that only I am accessing the data, but we also have but in the background we are doing concurrent access. Other is again reduce the other advantage is crash recovery. What if the SSD fails? How to recover the data back? Now reduced application development. Clearly DBMS supports important functions uh, that are common to many applications. Given all these advantages, it's a so the number of advantages overcome, right? Uh, Overcome why we shouldn't be using file system access, right? So hence, to manage data directly, you can store data in a file system, but then you won't be having these features, right? We can have concurrency control, crash recovery mechanisms. So this is what is a management system making or helping us, right? Then we have something called as the relational model. Now in this section, so before going on to relational, uh, now the user of a DBMS is ultimately concerned with some real world enterprise. And the data to be stored describes various aspects of the enterprise. For example, there are students. A data model is again a college level high level data per description constructs. A DBMS allows a user to define the data to be stored in terms of a data model. Most databases management systems today are based on RD relational data model. We'll see what is the relational model. One data model DBMS has many detail is nonetheless closer to how DBMS stores data than how a user thinks about the underlying enterprise. The semantic data model is a more abstract. Mm, this is all a little bit introduction. Now comes the relational model. Now in this we'll see, or before we go that, uh, there is a lot of confusion, right? Whenever you are, um, whenever you, so then let's see. What what happened to my pencil? Doesn't seem to work. I am. Oh, it should work. Go to settings. Yeah, just give it 2 3 minutes to. We'll see. Okay, let's see. Different types of DBMS, like different types of management systems. So data model basically describes how our data is being stored. Uh, I need to. The first is RDBMS. Again, you have uh, different types of databases management. Then you have, okay. We'll see how to install in VS Code. We'll see that linking as well. We'll see everything from scratch. So yeah, let's close this for the time being. Okay. Yeah. So now let's I'll just give it 2 3 minutes more. So we'll try to use VS Code interface. Uh, then we'll see what and how we need. Okay, I guess this is more than enough. Just give me 1 minute. Okay. Let's have the right, not this thing. Let's wait. It's not detecting the sidebar. Okay. So now basically we said uh, we are so we said that we need a software to manage, right? So we need a database management system, right? So now there are two things. Uh, there is something called as data model. So data model basically represents how are we storing data, like what model are we using to store data. So it basically represents now this data model. There are different types, right? You can have data being stored in the form of relations, or more crudely we can say in the form of tables. Then you can have object based. You have NoSQL databases again. Then you can have object OOP based or object based. So for the timing, we are only going to uh, so first we are now right now we are going to search. We are only thinking a data model is uh, our data model is relational, right? So this means uh, data will be stored in uh, so we will store data in data in tables, right? So now to manage data stored in um, tables or relations, we will use something called as uh, a relational database management software, right? We'll be using a relational database management. Now this is going to manage the data. So this is managing data, or you can say relations. Okay, so this so far we are good, right? So now we are going to do RDBMS, or more technically relational database management systems. Now, so this is a software, right? So first point is this is a program. It's a program or a software. Now what it does is it uses structured query language or SQL to manage data, right? SQL to manage. Now there are different okay. So now let's see okay, so now we have different types of um, uh, RDMS management software, right? So basically, now this for further we can have different types. Okay, either you can have MySQL, you can have these are all types of SQL. You can have PostgreSQL. You can have Oracle. All these are all RDBMS. That is, they are going to work on relational databases. Then you have Microsoft SQL Server. You have SQLite as well. Again, that is an RDBMS. Basically, you have my SQLite. Again, light version. This is for mobile application. So RDBMS is going to use something called as SQL. Now, um, there are different types of so uh, the data that we are going to manage is uh, relational. It uses SQL. Now there are different. We can say there are different variations of SQL by different companies, right? So some minor changes in everything. You have MySQL. You have Postgre. The core concepts of a relational database will always be sufficed. Then you have Oracle. You have SQLite. You have server. This is again Microsoft SQL Server. Okay. So now we understood the different types of uh, RDBMS, right? That is the software to manage relational databases, right? Uh, now, okay. So now let's see more about. Okay, wait. Let me check. So we say let's go a little bit deeper. So at the root level, we would be storing data in some sort of hardware. So this is the hardware, right? So here is where our data is brushed. Now if our this stored data is in the form of relation, then we'll be to manage this we'll be using something called as RDBMS program. Okay, this makes sense. Now uh, now let's see what is MySQL server. Okay, okay, so Now there is a problem, right? If you see over here, so our hardware cannot understand data in the tabular, right? So hardware will only understand transistor language, right? Or if this is an HDD, it will be using disk writing, or if it's an HDD, then it will be using what do you say? Uh, so here everything is one and zeros, or if it's a disk, it's how the disk storage works. Now what we need is, so we don't want this. We want our data to appear as uh, in the form of a table, right? We need this table to appear. Now he's going to do the conversion from this to this is what. So here is where our DBMS will come into play. So DBMS is sitting over here somewhere. You can call it that. So so after, so the interaction between hardware and data. Is it so? Yeah, so basically this in between call, so this is where our DBMS is sitting. Yeah, so this is how our, or at what level DBMS is present, right? So that database is DBMS is what is going to call the OS. Okay, now there is something called as SQL, and okay, now this has to be some interpreter type of thing, right? So either it could be a MySQL server, or you can have a uh, PostgreSQL, something like that. Anything. Okay, so the DBMS is sitting between the, it's between the application and what we see, tables that we see. So this conversion is what is done by DBMS. And if you see the other way around, the query that we write. So on our uh, so if the query or the SQL that we write here, this is going to go to the DBMS. The DBMS is going to go to the hardware, and then from the hardware it is going to do the specific operation. Then this is the output, which is again taken from the hardware, and we see it on our screen. Okay, so now how to so basically, if I need a the first thing that I would need is basically something called as a DBMS, right? That is understanding my rows and tables. So I need this software to be installed. The first thing is I need a DBMS, This can be anything. There are multiple. There are Postgre, however, whatever you want to do, you can use. So let's yeah. First is we are going to now by when we say okay. So let's install the DBMS first. The way to do this is we are going to do pip install maybe homebrew. Yeah. Okay, wait. We'll do MySQL. Oh, wait. Uh, Postgre. No, we'll do MySQL. We'll install MySQL. I feel that is best. Yeah, we'll have this thing. Okay. Let's install. Okay, we'll do MySQL. Let's open terminal. Wait. Control. We need to stop this. How to? Oh, let's right. Let's perfect. Now let's uh, uh okay. So first let's have our let's now work with the installation. So let's turn this off. Let's this is this is bank, right? Then this has to be side. Let's end this thing. Let's open our terminal. I've already deactivated my venv. So let's install. You can either get it from, but then that brings the workbench and okay. So first is we need to do this. Wait. Let's update the. We are doing via home, bro. Let's get it updated. You have three outdated formula, blah 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 blah. You can upgrade them with. I did do though. So it's brew upgrade. Uh, Let us complete it. Yes. And this is my secure OS. Let it upgrade whatever is. Oh yeah, this is, it's kicking from some GitHub repo. Let this complete first, then we will see little bit. So right now we are working on installing DBMS. Is it done or it's done? I guess no, it's happening. Let it happen. Sorry, try again. Or is it asking for my uh this is yeah, it's oh, it's complete now. Now let's do let's start the install. So do brew install MySQL. Let it go. It's fetching. Let it complete. Pouring. Secure.bottle, the tar.gz. It's the same thing though, even if I get it from the side. The tar.gz file is what we are looking at. Let it complete. It should ask me for a password though. So right now it's insecure, so user is wait. User equal to JE. Okay, MySQL is, we have installed our MySQL database without a root password to secure it. Oh, so I haven't given any password yet. Let's give it. So to secure it, let's give it a password. Secure. So remember, if you forget this password, uh, then it is going to be a headache. Should we go for this? I guess yes. Now enter the password. Now remember, you need the root login, else you will fail. So okay, now to connect, MySQL is configured to allow connection from local by default. To connect, run MySQL-u root. Okay, can't connect. So now you have to log in. I have to do MySQL -u root and then hyphen. Does this ask for a? Yeah, this is error. Can't connect. This is something. Let's see the error though. Oh, we need to start the server first. Successfully started MySQL. Okay, let's check if it's running. Yeah, so Jupyter Lab, MySQL, perfect. Oh, it came over here. MySQL, blah 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 blah. Yeah, this is the new Apple thing. Now let's try connecting to it. It may ask for a password. Access denied. Oh, this is not good. MySQL hyphen u. Welcome to our MySQL monitor commands. Wait. Oh, so now my MySQL has started. Access denied for user root using password. Yes. Oh, there's something now. This has done, but I don't know why doesn't it open for. There is not going to be any database. It is going to give me none or something. So I have my. Oh, this is the default thing that has come. Let's select all. And what is the data? And let's select from information. Oh, have I to? Let's. Okay. On how to end this. Control C. Brew services. So I'm going to do brew. Alright, let's do brew. Oh, this is we are inside some. Uh, wait, we are something doing wrong. Let's go back. Do you terminate? Oh, I can close and terminate. The way to start is I already have that data, right? Yeah, brew services start. So now MySQL has started. Okay, restart. Then now what's the difference between hyphen u? What's the difference between these two? Or let's try to connect the root. Error access denied. Using how to reset is something. So what we can do is it's going to stop. Oh yeah, it's stopping. This might take a while. Now let's do this. MySQL server stop could not be found. Oh, it's an alternate thing. Okay. Now let's try running it in safe mode. Login without a password. No, wait. Oh, it's asking for a password now. Very terminal go. Okay, let's see. Let's try this. Or is this like giving process ID or something? It's again ended though. It starts and it ends. Let's try to open this. Can't connect. Let's start again. Oh, right now it's not ending. Let it complete. I didn't got I didn't get the ended thing right. So we need to open a new terminal. Oh, connection is established now. I guess this is welcome to my SQL monitor. Let's so what's my new password though? Let's keep it simple though. Yeah, I don't want any. Let's just keep is this. Oh, now I can. Yeah, let's keep it this. I think this is best. And then I have to do this. So it should be